Hey guys, in this video we're going to take a look at marginal probability distributions and marginal density functions, and then in the following videos we'll take a look at conditional probabilities distributions when we have joint density and probability functions. Right? So first let's define what we mean by a marginal probability function and a marginal density function. So a marginal probability function, here we are looking at jointly discrete random variables. If they have a joint probability function that is p of y1, y2, the marginal probability functions of y1 and y2 respectively are given by, so our marginal probability function for y1 is p1 of y1 is equal to the sum over all values of y2, p of y1, y2. Right? So to find the marginal probability function of y1, we are going to, for each choice of y1, we sum over all options of y2. And similarly, we do the same thing for y2 to define the marginal probability function of y2. So we sum over all options of y1 for each value of y2. Right. So what these marginal probability functions are going to tell us is they're going to tell us what is the probability that y1, that big y1 takes on the value of little y1 without regard to the value of y2. So it's adding up all of the values of y2 and just saying, what's the probability that our value of y1 is equal to little y1? And so that's a similar thing that's going to happen with our density functions. So when we have jointly continuous random variables with a joint probability density function, f of y1, y2, then our marginal density functions of y1 and y2 respectively are given by f1 of y1. So here we're going to integrate from negative infinity to positive infinity that joint density function. But here we want to describe what are all the probabilities of y1, and so we are going to integrate over all choices of y2. So we're integrating with respect to y2. If we want to find the marginal density function for y2, then we integrate over all choices, integrate that joint density function over all choices of y1. So those are our marginal density functions. You either sum or integrate over the other random variable to find the marginal probability function or density function. All right, so let's take a look at an example. For a group of 3 Republicans, 2 Democrats, and 1 independent, a committee of 2 people is to be randomly selected. Let y1 denote the number of Republicans, y2 denote the number of Democrats on the committee, and let's find the joint probability function for y1 and y2 first. So the joint probability function of y1 and y2, that's what we'll do first. So let's think about this setting. So y1, that's the number of Republicans on this 2-person committee. There are 3 Republicans that could possibly be on it. So the number we could have on it is either 0, 1, or 2. We could not have all 3 people be on a 2-person committee. That makes no sense. For the number of Democrats on that committee, we could have either 0, 1, or 2 because there are 2 Democrats. And so we will find specifically the probability that the number of Republicans on the committee is exactly 1, and the number of Democrats on the committee is also exactly 1. And then we will, I'll create a table that kind of fills in the other values, but this should give us a sense on how to calculate those. So from among the 3 Republicans, we are going to choose 1. From among the 2 Democrats, we choose 1. And from among the 1 independent, we are choosing 0. Right? So that is the number of committees that consist of 1 Republican and 1 Democrat that could be formed out of these 6 persons. And the total number of 2-person committees is 6 choose 2. And when we calculate that, we end up getting 6 over 15. So that is the probability that a committee has exactly 1 Republican and exactly 1 Democrat. All right, and so if we did this process over and over, our values of y1 and y2 could be either 0, 1, or 2, and 0, 1, or 2. The probability that we have 0 Republicans and 0 Democrats on this 2-person committee, that probability is 0 because we have only 1 independent, and so we would only be able to have 1 person on the committee. Similarly, we are going to have its probability that we have exactly 2 Republicans and 2 Democrats is going to be 0, or 1 of one and 2 of the other is also going to be 0, because any of those committees would actually be forced to have more than 2 persons, so that makes no sense to have a 2-person committee with 4 people on it, or a 2-person committee with 3 people on it. We previously found that value right there is 6 out of 15. So their probability that we have exactly 1 Democrat and 1 Republican is 6 out of 15. And our other values here, this would be 3 out of 15, 3 out of 15, 2 out of 15, and 1 out of 15. All right, so those are the other probabilities. All right, so this right here that we just found, that table is really describing all of the probabilities that we could get jointly for y1 and y2. That is our joint probability function. Right. So now we want to find the marginal density function, or marginal probability function of y1. And so for y1, what we want to do is we want to add up. So when our value of y1 is equal to 0, we are going to add up over all choices of y2. And so we add up just that column, 3/15. And the second one, we add up the column, 9/15. And we add up the column, 3/15. Right. So there are those totals across the bottom. Those are describing, so that first value of 3/15 says the probability that we have exactly 0 Republicans on the committee is 3 out of 15. The probability that we have exactly 1 Republican on the committee is 9 out of 15. The probability that we have exactly 2 Republicans on the committee is 3 out of 15. Right? So it describes those, and it doesn't say anything about the number of Democrats on the committee. We could also take, instead of column sums, if we took row sums, if we added that first row, we would get 6 out of 15. Adding the second row, we would get 8 out of 15. And then 1 out of 15. These row sums, that would be a marginal probability function of y2. So 6 out of 15 would be the probability there are exactly 0 Democrats on the committee. 8 out of 15 is the probability there's exactly 1 Democrat on the committee. And 1 out of 15 is the probability there's exactly 2 Democrats on the committee. All right, we'll talk to you next time.